So in the tutorial, I'm going to go through the integration of cos squared x and cos cubed x. Both require a formula, but they each require a very different formula, and if you use the wrong one, you won't get anywhere with it. So you've got to remember, when doing this, these two integrations by inspection that we've done previously. So you should know that cos 2x integrates to a half sine 2x plus c, and sine squared x cos x integrates to a third sine cubed of x. Okay, so bearing those in mind, let's start with cos squared of x. Now, I prefer to write formulae down on the right hand side of the page and the main part of the working in the left hand side or centre. So this one requires the expansion of cos 2x, which is 2 cos squared x minus 1. Now if you rearrange that, so do this in 2 steps, cos 2x plus 1. So start by adding 1 to both sides. Cos 2x plus 1 is 2 cos squared x, and then halve both sides. You can do it separately if you want to, but I think it's probably easier to do it like that and to get that half out the front of the integral side. So equals a half integral of cos 2x plus 1. So this is a half, so we integrate that and we get a half sine 2x, integrate 1, x and plus c. And if you want to, you can expand that out into a quarter sine 2x plus a half x plus c. Right, so that, the cos squared x requires the cos 2x formula. Now the integral of cos cubed x requires sine squared x plus cos squared x equals 1. And we want cos squared x, so cos squared x is 1 minus sine squared x. So if we write this as the integral of cos squared x times cos x, box that off. So this is 1 minus sine squared x times cos x. Expand out. Squared x. So integrate cos x, you should know by now it's sine x. If you don't, remember the s to c minus s minus c. If you differentiate that way, integrate anticlockwise. And here, this integral comes into play, so we're going to get minus a third sine cubed x plus c. So this formula will not work with the integral of sine squared or cos squared, and vice versa, the cos 2x expansion is not appropriate for this one.